I'm Raquel Villanueva, coming to you live from NASA's Jet Propulsion Laboratory. The conditions that spacecraft endure are pretty extreme. The intense shaking of a rocket launch, the jolt of the rocket separating, the extreme temperature changes, and of course, the unforgiving vacuum of space. That's why, before launch, engineers do their best to replicate these harsh conditions. Behind me is a JPL space simulator, and it is an active space here in this facility, so you will be able to hear some noise of the airflow in the background. And the Europa Clipper spacecraft was tested here not too long ago. It was tested here to make sure it would be able to operate in the extreme conditions it will face on its trip to Jupiter's icy moon. This was one of the final phases of testing here at JPL before Europa Clipper heads to Florida's Kennedy Space Center, where it is set to launch this October. Today, we're going to walk through the testing and Europa Clipper with the help from some of the members of the team. Now, if you have any questions you'd like to ask, leave them in the chat, and we'll get to them in just a few minutes. But first, let's talk to Annie Marinin, who is a Deputy Payload Systems Engineer. Hi, Annie.
Hi, Raquel.
Welcome to the Space Simulator.
Thank you.
So, first question on everyone's mind, what is a space simulator? Is that like an anti-gravity chamber?
It is not an anti-gravity chamber. What this chamber behind us does is three main things. One is that it allows you to pump out all the air so you can actually test in a vacuum. And the other two are related to temperature. So one of them is we can cool the walls and the floor of the chamber using liquid nitrogen to simulate the very cold background of space. And there's also a sun simulator, so you can simulate the radiation that the spacecraft will feel from the sun as it travels to Europa.
And I heard that the sun simulator lamps are located in a different part of the building.
Yeah, so there's more to this facility than you can see right now. The sun simulator is about 3 stories down, and it shines up to a mirror at the top of the chamber, and then the sunlight comes down from the top. And the really cool thing about that is we can actually control the temperature of the sun and how much power we get, because as the spacecraft gets closer to Jupiter, the sun gets dimmer from its perspective.
And Annie, why is it important to test spacecraft like Europa Clipper in this facility?
So this facility is the only chance we get on the ground to actually test the spacecraft in the environment it was designed to operate in. And I'm the Deputy Payload System Engineer for Europa Clipper, and I get to work with all of the instruments. And so some of the instruments we can't fully operate in an ambient environment. So we use this chamber to actually fully test out some of those instruments. So we have high voltage that we can't run safely in ambient conditions because you don't want it to arc. And we have some elements that are designed to only operate at very cold temperatures. And you only want to do that when there's no air or water that can condense onto ice on your instrument.
You know, this facility is a National Historic Landmark. That's pretty cool. Can you tell us more about the history and the missions that have been here before in the past, before Europa Clipper?
Sure. So this facility was developed and built in 1961, so a long time ago. And basically every major mission that has come through JPL has gone through and tested in this chamber. So things like Voyager and Cassini and Galileo and the Mars rovers Curiosity and Perseverance and Psyche, and just a couple weeks ago, Europa Clipper.
And what was it like being in that space? You got to go in there, correct?
I did. They let me crawl under the spacecraft.
Wow.
Yeah, so it was very cool. It's dark in there, so when the sun is not on, there's a lot of, so this picture shows it with the sun on, so you can see all of the hardware illuminated. But there's, like, the walls are completely black. And yeah, going in there, it's a very cool, like, you're just surrounded by black walls when you're in there, and there's a spacecraft just right above you.
And what other tests did Europa Clipper have to go through?
There's a whole environmental test campaign that all spacecraft go through, but for Europa Clipper it started last fall. It's been months long. The first thing we did was a dynamics test. So we had the spacecraft go through a vibe test and an acoustics test and a separation test. So we're shaking the spacecraft, and also, if the acoustics test, putting it in a chamber that has speakers surrounding it and just blasting sound at the spacecraft. And the whole point of that test is to really show that it will survive the launch environments. Like one of the craziest things we do to the spacecraft is launch it. next major environmental test we did after that, it was called an electromagnetic interference and compatibility test. And so on that one, we're actually turning on different boxes on the spacecraft and making sure that when you turn one thing on over here, it doesn't cause noise or interference or feedback or anything on other parts of the spacecraft. Wow. And then the last one was the thermal vacuum test, where, again, we tested it in the environment that it's going to operate in.
Well, thank you so much, Annie. I know we'll have questions for you later on when we have social questions come in. And up next, I would like to welcome planetary scientist Elodie Lesage.
Hi, Raquel.
Hi, thank you for joining us today.
Thank you.
So we learned all about Europa Clipper. Now it's time to learn about Jupiter's icy moon, Europa. Can you tell us more about it?
Yeah, so Europa is approximately the size of our moon, so it's pretty small, but it is entirely covered in water ice. And more interestingly, below this water ice, there is a global saltwater ocean, as you can see on the animation. So this ocean is 60 miles deep, so it's a lot of water. On Europa, we have twice as much more water than on Earth. So if we combine all the oceans of Earth, we have still twice more water on Europa, which makes it pretty special. There's also, on the surface of Europa, plenty of amazing geological features, which tell us that Europa is a very active body, which makes it very interesting, and this is why we want to go to Europa.
And I'm also curious to know about your role as a planetary scientist on the mission. Could you tell us more about it?
Yes, so on Europa Clipper, I am a postdoc affiliate in Project Science. So Project Science is the group of scientists that are responsible for the scientific success of the mission. So for example, they define the goals of the mission, so why are we going to Europa? And then they ensure that we have a procedure to answer all these big questions. And so this is the team I am a part of.
And what are you hoping to answer as a scientist when it comes to Europa?
So personally, my research focuses on the transport of water from Europa's ocean to the surface. So I wonder if it is possible that there's water that can travel from the ocean through the ice shell and then erupt at the surface through little ice volcanoes. So I do a bunch of numerical simulations to understand this, and I use data from past missions. And so this is also why I'm super excited about Europa Clipper, because I'm finally going to have new pictures of the surface and measurements of the atmosphere of Europa to answer this big question.
We can definitely hear your passion for Europa. Can you tell us what you love personally about the ocean?
Yes, so Europa's ocean is very unique in the solar system because it is in contact with the seafloor, the rocky seafloor. So just like on Earth, the deep of the ocean is in contact with rocks, right? So this allows a lot of chemical exchanges between the water and the rocks, which make the ocean really rich in chemical elements. And on the other end, at the surface of Europa, there is a lot of very harsh radiation from Jupiter that also creates chemical elements. And if these can travel through the ice shell down to the ocean, this can provide the energy to sustain maybe life at Europa. So whether this actually is happening or not at Europa is still an open question, and this is why we really want to go there and why it is such a unique place in the solar system, because it's the only one to have the combination of these two things.
Well, thank you, Elodie. Those are all the questions I have for both of you. Now it is time to answer your questions that are coming in through social. So let me pull them up right now and see what we have. All right. The first question is from Tarl Cabot on YouTube, who wants to know, what precautions are in place to prevent cross-contamination when sampling Europa's ocean/ice shell?
Okay, so if by so we have, I'll talk about from a planetary protection contamination perspective. Yes. So we do have a planetary protection program on Europa Clipper and contamination control. So we do a lot of sampling and a lot of cleaning of almost every surface on the spacecraft periodically throughout the whole ATLO test campaign. So we have requirements on how clean things need to be and the materials that we use that was all informed by contamination and planetary protection requirements.
Yeah. And for that, you also have to wear special suits, too, to be in those rooms.
Yep, we wear bunny suits. That's what we refer to them as.
Can you kind of like describe what a bunny suit is?
Yeah, you're basically covered head to toe in like a flexible plastic. You wear face masks, you wear head coverings and shoe coverings, and gloves, and you tape the gloves to, like you can see in this picture here. Like basically all you can really see are the people's eyes. So you get very very good at recognizing people from how they walk and what their eyes look like.
Well, thank you so much for that. Next question is Fax Machine Mode on Twitch wants to know what capabilities will Europa Clipper have that Voyager, Galileo, and Juno didn't have?
Ooh.
Yes.
Europa Clipper has a lot of capabilities, I think, but what's really new is the resolution of these instruments is going to be much higher. So the pictures we're going to have of the surface, for example, are going to be much higher resolution like we've never had before. We're also going to sample for the first time particles from the atmosphere of Europa, which we couldn't do before, and analyze them. We have 2 instruments that are going to capture particles and analyze them. So this is pretty new too.
What instrument are you most excited about?
Personally, I would say it is the cameras that I'm the most excited about, just because these low-resolution images we have from Galileo are, to me, extremely frustrating because I want to know what the surface looks like exactly. So now, I'm just waiting for high-resolution images to know what it looks like. Like, do we have little, what size are the little rocks of water ice? Like, I want to know what the surface looks like.
And what about you?
I don't know if I can give that answer. I'm like working on all of the instruments. The one I started with is UVS, which is the ultraviolet spectrograph. And that one, like, it's the closest to home for me because that's the one I started on Europa Clipper. But that's when we call it the plume hunter for Clipper.
Yes, that was a very diplomatic answer too. I appreciate that. Yes. Sai on YouTube asks, the existence of vapor, of course, makes Europa a very promising candidate for possible life. But what gave Europa precedence over other moons of Jupiter as well as moons of Saturn?
For the moons of Jupiter, Europa is the only one where the ocean is in contact with the rocky floor. The other moons have something that is pretty special too, but they have a layer of high pressure ice at the bottom of the ocean. So the cross section would look like ice, water, ice, and then the rocky floor. So the ocean interacts less with the rocks, so there's less room for chemistry. And for the moons of Saturn, there's Enceladus that is extremely also interesting, and where we might go in the future because it's also being prioritized by NASA for the next decades or so. Enceladus is also extremely interesting.
Thank you. And we have Philip on YouTube who asks, how long will the spacecraft be operated once it reaches Jupiter?
So once it reaches Jupiter, I think there are a couple years of like primary operations, and then every mission hopes to extend past that. But I think we're planning for a few years once we actually get to Europa.
Great. And Andy, someone wants you to know that they are digging your earrings, your NASA earrings.
Thank you.
And we have a new question coming in. It is from Lord Aranosaurus on Twitch asks, when Europa was discovered, how long did it take for scientists to learn about the water?
So Europa was discovered long ago by Galileo, and we went there for the first time with Voyager. And for the water, so we've always known that it's covered in water ice. The ocean was confirmed with the mission Galileo, so like in the 2000s. We suspected that it was there before that, but I would say, yes, Galileo was the confirmation for an ocean at Europa.
Next question is from Stanimita on YouTube who asks, what is the most innovative instrument of Europa Clipper? Kind of follow up to our instruments question.
So there's one called mass specs, which is a mass spectrometer that I think that one, it's one of the more complex instruments. So it's one of the ones that's sampling particles from the atmosphere. But if you look at it, it kind of looks like a ray gun. So it's one of the most groundbreaking new technologies that if it works and it works as expected, it's the best resolution of that mass spectrometer that will have flown.
Do you have anyone you'd like to add, or?
I would agree with you. I'm also pretty excited about mass specs, and it's definitely a very high technology instrument for sure.
Next question up is from Sandro on YouTube, who asks, what would we expect to see carbon-based life forms in the ocean or based on some other materials in case there is life to be found on Europa?
So Europa Clipper is not a mission made to detect life or characterize it, right? We're going to characterize the environment at Europa to understand if life could survive or emerge there. So we do not have instruments to characterize life forms on Europa, and we couldn't tell, if they're carbon-based or something else. This is obviously a very interesting question, and I hope that one day we'll have an answer.
And for everyone who is just tuning in, we are inside a facility that has a JPL space simulator behind us. And if you hear kind of some airflow noises, that is just from the space. Annie, can you kind of explain why we're hearing what we hear right now?
Oh, I can try. There's a lot of just vents and airflow in the room. So the whole chamber is supported by a series of pumps and vents and air ducts and everything. So I think it's just a lot of ambient noise that comes along with supporting a chamber like this.
And of course, we have our experts, Annie and Elodie, with us. So if you have any questions about the testing that goes on here or Europa Clipper, you can drop them in the chat. I am reading them as we speak. So the next one is from Toolbox Robotics on YouTube, who asks, is the data transmission power of the Europa Clipper to Earth greater than that of the previous spacecraft?
In general, yeah, we have a high gain antenna. Most spacecraft that go all the way to Jupiter or beyond, you need a high gain antenna to transmit back to the Earth. So it's not going to be as high powered as the ones that went farther from Jupiter, but we try to expand on capabilities and try to get as much data as we can. And the more instruments you have, the more data you need. So we definitely need the power to get all that data back.
Great. And the next question is Osteopolar on Twitch asks, what protections are in place to keep the spacecraft from accidentally contaminating the moon's oceans?
So Europa Clipper is not going to touch the surface or the ocean, right? It's only going to perform flybys of Europa, so we're not landing. So this is one of the most, the best thing we can do to protect Europa's ocean. But also, as Annie said, the spacecraft is extremely clean. It's always at each single step, it is completely cleaned, and we check using little swabs that there's no contamination in the spacecraft. So, and also, the travel in space is going to end cleaning the spacecraft, because life forms, most of them on Earth, could not survive such a travel. So it's expected to be pretty clean when it arrives there.
You mentioned the flybys. Can you kind of expand on what that will look like for the viewers at home? How many will happen? Kind of the trajectory.
Yeah, sure. So Europa Clipper is actually going to orbit around Jupiter. It is not going to orbit around Europa, because at Europa, the environment is very harsh. There's a lot of radiations that would damage the spacecraft very severely. So to make it last longer, we're going to orbit Jupiter. And every orbit, we're going to perform a flyby of Europa. So we're going to fly by the surface, turn on all the instruments, take all the pictures, the measurements, and leave until the next flyby. And so we're going to perform 50 flybys nominally. So this is what the mission is going to look like.
Hey, and I know we touched on this question, but for those just tuning in, that Opal guy on YouTube asks, what is the mission duration nominally?
So nominally, there's about 6 years of cruise after we launch before we actually get to Jupiter. We do a flyby of Mars, do another flyby of Earth, and then swing all the way out to Jupiter. After we get into Jupiter's orbit, it's a few years of operation and doing the flybys of Clipper.
And now we have John Ralph on YouTube, who wants to know, How do we know Europa has a rocky floor?
So by taking measurements of the gravity field of Europa, we can learn about the density of each layer. And so rocks are very dense, so they're pretty easy to identify, right? Rocks and iron cores can be identified pretty easily using gravity. So this is what we have on Earth, right? We have a iron core and then rocks around it and then oceans on top. Europa is just the same as a iron core, a rocky mantle, and then a global ocean, and then the ice crust because it's very cold there.
And then Greg Mandel on YouTube wants to know, will the spacecraft fly by any plumes emitted by Europa?
Hopefully, I hope so. So if there are eruptions of water from the inside of Europa, yes, we would observe plumes. We're unsure that this is actually going on at Europa. We're unsure that there will be active plumes at the moment when we're there because, we would need to be pretty lucky to observe this. But hopefully, we'll fly by a plume and be able to sample some of the material.
A plume can be described in many ways. Like, can you tell us what is thought to be a plume in Europa?
Yeah, you could picture kind of a geyser, so like a plume of vapor, water vapor, transporting some material from the subsurface. So, for example, salt or little chemical elements. But yes, I would say water vapor and little ice grains.
Great, thank you. Now, Jokesmore on YouTube wants to know, can you simulate Jupiter's orbit conditions on the space simulator, which is behind us right now if you're just tuning in?
Yeah, so kind of. The space simulator kind of focuses on the sun and then like the background of space. So from a thermal environment, we definitely do simulate the flux from the sun that the spacecraft will see at the distance of Jupiter. Jupiter is about 5 times farther from the sun than Earth is. But another thing we can do, so that's just thermal, but we run other tests using computers and things plugged into the spacecraft to make it think that it's orbiting around Jupiter. And so it will run the wheels and think that it's fired thrusters, and so we can check out all of the operations of the systems together by kind of spoofing those signals.
And then we have another question coming in from Staminita again. What was the most difficult instrument to make and how does it work?
Again, I don't want to have an undiplomatic answer. So every instrument it's like we're building things for the first time, and that's one of the most exciting things about Europa Clipper. We've got a suite of 9 instruments plus a gravity radio science experiment, and so they all have kind of their quirks, but also their really cool science that they're doing. So I think they range, and like every single one is kind of very complex in its own way. So it's a little hard to just pick one of them that's the most.
That was a great diplomatic answer once again, Andy. Mortisil on Twitch asks, my 10-year-old son Ronan asks, is it possible that there are plants growing under the ice on Europa?
That there is what growing under the ice?
Plants.
I'm sorry. Plants.
Yeah.
So plants technically need some sunlight. So I would say that if there is anything in Europa's ocean, it does probably not look like plants like we have on Earth or, any life that we have on Earth. I think it would be pretty different. But we don't have more information. So, pretty much anything is possible.
And we have Jack on YouTube who wants to know, will the mission be crashed like Cassini when it's over? Can you kind of describe what the end of mission will look like?
So my current understanding is that we are crashing into Ganymede. So it's not exactly the same as Cassini. It's not going into Jupiter, for example, but that is my understanding of the current end of the mission.
And then we have S13KS, who has a question more about the images that will be coming in. Will Europa Clipper give us detailed images or videos of
giant penitentes?
Yeah, I want to make sure I got that correct.
Penitentes are kind of like ice spikes that can form when you have very specific light conditions and in very cold environments. And it's been discussed whether it exists or not on Europa. And we do not have an answer yet because we couldn't see them on the Galileo images because the resolution is too low. So if there are penitentes at Europa, we should see them on the new pictures. But again, it's really unsure that they actually exist there. And what was the question about?
I'm just asking about like the imagery. Like, will Clipper give us those detailed images?
Yeah, it's gonna be very detailed images, and for videos, I don't think so. But just like series of images.
We'll have the images there for you.
Yes.
Striker on YouTube asks, is this mission the beginning of many other missions?
I hope so. It might depend on what we find there.
Yes. Also, this is a question that comes up a lot when we have these type of lives, is how did you get into your career fields? People love to know how you got into this mission, so I'll start with Annie.
Sure. So I actually wanted to be an astronaut when I was little. So I kind of stumbled upon aerospace engineering as a field and looking into career options when I was little. Didn't know it existed before high school, but I decided that's what I was going to major in. I now have 3 degrees in aerospace engineering, and it wasn't until I was in undergrad that I really knew what JPL was. So I came to JPL kind of right out of school, and I've loved it ever since. But I chose aerospace engineering because I thought that sounded like I love space engineering. That's perfect. But there's so many different kinds of backgrounds for everyone that works at JPL.
Oh yeah, for sure.
And what about you, Elodie?
So I started studying physics. I did all my studies in France. So I studied at the university. I studied physics as an undergrad. And then I studied planetary sciences for my master's program. And then I had a PhD in planetary sciences. And then this is when I discovered NASA and JPL and moved here for this amazing postdoc.
And what advice would you have?
What? I'm sorry?
Advice would you have for future students who want to get into STEM or maybe a career like yours?
I would agree with Annie that there's so many possibilities that can just lead you to this kind of careers. I work with people that studied chemistry, geology, physics. I work with engineers. So there's so many pathways that can lead you to this kind of things. Just dream big and never give up, and yeah.
We have time for one more question here. So really quickly, what are you both most excited about for the mission? Andy?
I think my biggest relief will come when we get kind of what we call first light on all the instruments, like turn them on for the first time and make sure they actually work and get the data that we want them to.
And what about you, Elodie?
I'm sorry, what was the question?
What are you most excited about when it comes to Europa Clipper?
Beautiful pictures, and also sampling of plumes if we sample plumes. But yes, definitely the pictures.
That is all the time we have for questions today. Thank you so much for answering all our questions today, and thank you for watching at home, joining us in the JPL Space Simulator. If you'd like to learn more about the Europa Clipper mission, you can follow at NASA JPL on Instagram, X, and Facebook. Thanks for watching.